afternoon, good morning, and good night, depending on where you are in Australia or across the world. Today on my bench, we have part 2 of the power supply to charger conversion. And during this video, we're going to have a look at 3D printing a casing. We're going to install a power meter, the charging cables, amongst other miscellaneous things. Let's get into it. And before I forget, COVID safety, we should wear a mask. Okay, now that you can barely hear me, let's get into it. To start with, on my bench, we're going to have a look at testing the power supply we made last time. To do that, we need our power supply. I'll just remove these little bolts from it. We need a power supply, and we need an Australian cable. Don't forget, I'm not an electrician, I'm not licensed in any way, and this video is not, should not mean that you follow anything that I do. This is just what I'm doing. It may not be correct. I'm doing my best to be safe, but it might not be correct, and I don't recommend that you follow it. So, right now what I'm doing is I'm just removing the insulation from the cabling. This would be a lot easier with a proper tool, but this bloody thing doesn't work for some reason. I think someone's tightened it too far, but it just doesn't work in this case. I might break it. Okay, I'm just going to strip the ends of these cables real quick. Now, in a perfect circumstance, we'd use spade connectors to actually attach these. That'd be the most reliable, but I'm lazy, so we're going to not do that for the moment. And we're all good. Let's connect it up. I'll just bring that to the camera. Nice. And we're ready to test it. I'll have you guys with me for the big moment, because if it explodes, I want it to be on video. Okay, here goes. It's on. It's on, and it's not broken. Well, it's not exploding. Let's take a look with a voltmeter to see if we can figure out if this is producing output or not. Here we go. Hopefully you can see that. I'm going to connect to it. We have 11 volts of output. So let me go through with a little screwdriver and see if we can adjust it. Okay, simple tiny flathead screwdriver is all we need to adjust this thing. Spin it around. Our adjustment screwdriver just down there. They're just resting there, aren't they? No, they're not connected. Come on. There we go. Okay, let's give this a go now. Oh, that's annoying. So, I'm gonna just zoom in on that real quick. 39.2 volts is the maximum we're going to get out of the supply, which is a problem for me because I need 41 at least for charging. With that said though, for a bulk charger, this is fine. So just for doing the majority of the charging, you only really go up to 41 and 42 volts at the end of charge. So I could get 80% in with this, so that's fine. Here we go. So now we're going to have a look at the enclosure and the display. So I've 3D printed this enclosure out of black PLA plastic, and it's designed to have the display mounted and then to connect to the power supply, just right there on the sides. I'll put the STLs for this in the description so you guys can have a go if you want. Really easy for this one. It's actually in 2 pieces. So we orientate this edge with the front end of the enclosure and just push the screen through. So nice and simple display. And that'll just read out our voltage, current, and how much power we've put into the battery so far. Now, the inputs for this are very simple and also upside down. So you've got your DC input, the two center terminals, and the DC output at the two outer terminals. And pretty much all this will have is just a low value, low resistance resistor inside that will have a measurable voltage drop, a known resistance, and thus they measure the voltage drop to find the amount of current passing through. And as we know, current times voltage is equal to power. So they can do all those calculations with a little computer really quickly. So what I'm going to do is wire this up. I've got some just secondhand 18 American wire gauge cable. Look, this is not going to be carrying that much current. It's fine. What I'm going to do now is attach these wires to the correct positions in here. Now, pretty much all I have to do is just look through the grill again and figure out which section is positive and negative. Okay, this power supply has a really simple design. 3 from the right, they're all positive, and the 3 later on, they're all negative. So I'll just connect to the 2 center ones. All the crap off the bench. Here we go. So the display will look something like that. Very simple. And my output wires, I haven't got them currently. I'm waiting on the correct wires for them. But it'll just be connected to the 2 outer terminals. And they'll go off to my battery connector or something. I won't wire that up in this video because it's just a pain to do. I haven't got the wires and the connector right yet, so we'll worry about that later. But for now, I'm just showing you guys how to do this step. Next, the 3D printed display case. Yeah, that's it. So, as you can see, I've got 2 holes in here. The left one is for the output wires, and the right one is for the input. So unfortunately, I've got to go back through and remove these to fit it through this hole. Easy. So now I've got the 2 main things wired up for the power supply. So I can slide the casing back on, like so, and it'll line up pretty perfectly. I designed this for my power supply, so you guys might have to edit the 3D files if you want to make it perfect for yours. But it should work for quite a few of them. Next, I've got some M4, I think it's M4, yeah, M4 bolts and nuts. And they're actually what we're going to use to attach it to the side of the power supply. How lovely is that? Whoop, got switched around. BUT. And we've got our very own charger with display. That looks not too bad. The connections are still a little bit exposed down the top. I can fix that in the STL files. But she looks good so far. Let's plug it in. Okay. 39.15 volts, as we see here. Looks good. Making a really weird hummy sound though. I'm going to bring the phone in so you can have a look. It's very high pitched, but you might be able to hear it. Yeah, it's weird. Cool. So I think that's probably the switching transformer in there, so the bit that converts high voltage to low voltage. Having such a range of voltage adjustment means that sometimes the circuitry just isn't happy about it. So this is probably the squealing sound what we're hearing. And in the end, it's not that bad. If it gets hot or causes trouble, then it's bad, but I'm not feeling any of that yet. I'm also not getting shocked, which is a good thing. Anyway, we can use some hot glue now to make sure everything's secured, especially the cables. We don't want this getting pulled on and then coming out, so I'll just do that. Okie dokie. So what I'm doing now is I'm going to test the current output of the power supply. Lithium batteries generally charge in 2 stages, which is a bulk charge where most of the charging happens, and it's a constant current charge because the lithium batteries will draw as much current as they want whilst they're charging, and so we've got to limit it, therefore constant current. But on the other hand, at float charging, or not float charging, but like an absorption kind of charge, where the lithium battery voltage is at its maximum safe level and the current's slowly dropping off, that's a constant voltage stage, right? Because we're keeping the voltage at a certain level to make sure we don't damage it. So 2 simple stages for lithium battery charging, and right now I am just setting it up so that I can use this charger to charge a 12-volt battery, just so that we can make sure its current output is within a safe range. So I've stuck it back together. Hopefully that wiring checks out. Hopefully. There you go. And I've got it open in front of us because we're actually going to change this potentiometer, which controls the current. So let's do that now. Okie dokie, time to test. I've got it plugged in and set to 13.2 volts. And I've got a battery off screen that's draining right now through a discharging device so that we're constantly able to put current through. And right now it's pushing 4.4 amps. Now, being very careful, I'll go over to the adjuster switch and bring it up. I'm thinking we want about the 10 amp mark from this power supply. 10. There you go. 10 amps. Perfect. Okay, now that it's off, the screen's only being powered by the battery off screen. So I'm just going to reattach this now. And that's all done. The supply's back together. Now I'm going to do a load test on it and make sure everything's working properly. Make sure nothing gets particularly hot, and we'll go from there. Cheerio. Happy times. It works, guys. So we're done. Good luck. If you build it, let me know. It's very simple, and I'm going to see if I can make use of it. Cheers.